ready.
Are we starting at
7-4. Oh, should I do a spot check today? What about the spirals? I don't understand.
I have it.
Alright.
We all up in we all got it.
As long as I see him, I don't get frustrated and start doing little spot checks every day. That doesn't sound fun. If I start seeing no homework, well, I better start keeping you guys accountable.
It's the cool class, right?
Accountability, God knows what he's talking about.
Amen. Amen.
Alright, I'm seeing the notebooks, Here we go. Section 7.4, number 2, improper. That's when we divide. Number 6 is C, number 8 is A. You guys got it? 6 is C and 8 is A. Number 14. All you had to do was set it up. Go team, right? All you had to do was set it up. If you started solving, you are my hero, but read those directions more carefully. Why do you think I had them write them? So at least you have to read them and write them, and hopefully you don't miss anything that way. Number 22, final answer. Now, they write it weird. You could have written 4/5 over x minus 3 and 1/5 over x plus 2. Or you could have written that little 5 down multiplied by x minus 3 and that little 5 down multiplied by x plus 2. All of those are good. Does that make sense? Smile and nod and I'll feel better. Oh, good.
You're welcome.
Got any questions though? 4/5, 1/5, plug it in up top, or have it come down bottom, or factor it out to make it look pretty. Number 50. Woo!
I love it.
Yeah,
That guy was for sure.
Yeah, I definitely did not get that.
Did not do that one right at all.
Oh, come on, party first. Wait. Let's see what you did get. Did you get here? Look. Did you get here?
Yes.
Now, what method? Now, obviously, they chose one method. What did they choose? They chose like terms. They did the cubes, and then the squares, and then the singles, and then the constants.
That is.
Where's the actual answer? Is that the whole bottom thing? Right here?
Yeah,
It's the
you could have done the strategic values.
Because they took out that 6.
So you could have plugged in -2 easy and +2 easy. Just would have had to make up a couple more. Now, they write all these like words explaining the math. But you wouldn't have had to write all those words. The final answer is this.
Oh, it's not that equals part?
Well, it's this, and then they bring down the 6's, and they bring down the 3, and then they decide to like get common denominators and pull out a 6. Which is a very good calculus skill. Today's the 14th.
Tuesday. It's Tuesday.
Coffee tomorrow.
Wait, that was 36, right?
It's number 36. So A was -1/6, B was 1/6, C was 0, and D was 1/3, and then it popped down. Now, if you guys want us to look at this, we won't start here, we'll start here. Sound good? We'll come back to that in a second. Number 44, you do long division, and that's like, hey, keep going, except you can't.
So you're done.
This doesn't factor at all. So if you go to do a partial fraction, this would be the only denominator. So there's no splitting up. There's no farther you can go. So it might have looked hard, and yet, in all reality, it was the easiest one. Improper? Wait. Some of you got confused. Help. Anyone. Why is this improper?
Because the
degrees.
Yes. We divide whenever the degrees are greater than or equal to. Yeah?
Yeah.
Good?
Uh-huh.
Okay. You couldn't go any further, so you stop. Let's check 7.5 real fast, and then I'm guessing we want 36. Anybody say you added that? Oh, we're good. Does anybody want 36? Raise your hand.
I'll be the bright spot.
Ah, thanks, Sean. You saved the rest of you that really wanted to ask. Where's our confidence today? Because it's Valentine's Day. There's no confidence. It's okay, celebrate Valentine's Day.
Yes, that's what I said.
Okay, that's good. You can make it Valentine's Day. That way you guys can feel included too. Alright, number 14. Boys in the corners. Okay, 14. Long story short, you should have had a line with an intercept of -5 and with a slope of, I don't know. Down 5/3, so 5/3. Negative 5/3. Shade above, solid. Number 26, using your graphing calculator. How do you have your graphing calculator shade? Oh.
It was, you
I had it open.
You go to the left and then you do a bunch of enters until you get the.
If you have one of the newer calculators, yes, you can go to the left onto, well, actually, some of you can actually change your equals signs. I forget what the option is, though.
Yeah, you
Is it in apps? It might be in apps. That's a good call.
Yeah.
Which one is it? Inequalities. If you go to apps number 7, it looks like. If you go to apps number 7, you can actually change your equals, which is pretty spiffy. If you have an old calculator, though, that's not going to work.
I'm gonna try it anyway.
So when we go, oh, I don't want to delete all these equations. Hold on, guys. I'm going to put it in my Y4. I apologize, kind of. I just don't want to type it over again for calc. Actually, I can go to Y3. So I'll delete it when I go to Y3 for that problem. So what we were talking about this one, wait a minute. How, oh, get Y by itself, right?
Yeah.
Okay. So we get 2x squared minus 3. True. Yeah. Now, the old-fashioned way, for those of you guys with yellow buttons on your calculators, the older calculators, you can't change the equals sign. So you go back here and you say shade. Would you say above or below if it's a less than?
Below.
Look for the triangle. Nope, that's bold. Ooh, that's above. Nope, that's greater than. Ooh, that's below. So we can graph it and we can get it below. Dun, 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 dun. Except my Zoom is not in Zoom standard, so if I make it prettier, there we go. Except it's not very pretty. Oh, there he is. Ta-da. See? Isn't that spiffy? But what's the other way for those of you guys that found it? We were talking about apps a second ago, true? Let me go back and get the shading off. You guys have played with the circle. Oh yeah, we played with it at the beginning of the year, right? The circle you do and it shows where the graph is. No? Don't worry, we'll play with it again. Dotted, back to normal. Okay, apps. This one, right? The colored one. Number, oh, it's not like 7. Can you hit alpha and it goes to it? Which one's I? Is this one I? X squared? No.
Yeah.
Ah, there it is. I. Mine's way down low. You guys can type in a letter and they'll go to the I's. Ooh, Netherlands. Anyway. Some of you guys have gotten this and you're kind of frustrated with it. You don't like it. Maybe it's been on your calculator for a while. You can always go to apps and go to inequals and turn it off. I think you can quit. Probably not uninstall. That'd be sad. But then you could do less than. I think the bigger one is the less than, right? Is this one or equal to? You guys see it? Okay. So this one, which would be this one. Sadness. I don't want that one. Ta-da! And then it puts the shading on for you, and then you can go ahead and graph it, and it looks exactly the same. So if you want the cool little program, you can do the cool little program. Oh my goodness, it even did dotted because it's cool like that, cheaters. Anyway, so you guys do you. I'm going to go turn that off because I definitely don't want that still chilling. Inequals and quit inequal. Got it. And now it's off. All right, cool kids. It's an integral. Anyway, that's 26, 44. You guys have to solve with math. Substitution looks the easiest because anything else just wouldn't be fun. Even graphing it wouldn't be fun. Have a plus or minus square root, do 3 different equations. Plug it in, you get -3, -4, and 3, 4. Is that good? Uh-oh. -3, -4, and 3, 4. Okay, let's keep going, number 54. Last but not least, you were supposed to take a graph and find the constraints, is that right? Are you working backwards on 54? Cool. So from the graph, hopefully you got, now I would have written this differently, of course. I would have done y equals -x plus 4, just mx plus b then. Y is greater than or equal to -1/4 x plus 2. The ones you might have forgotten were x greater than 0 and y greater than or equal to, and y greater than or equal to 0. If you guys notice, it's only in quadrant 1. So whenever you see a portion of a graph only in quadrant 1, what are the restrictions that must be in place? Sorry. If it's only here, not only did x have to be greater than 0, but y had to be greater than 0 as well. So y had to be greater than and x had to be greater than. And that's how we get it in this region. You're so quiet. Okay, any questions on 7-5? No? Assuming we did 7-5 last week?
Yeah.
Okay. So it's just that easy, I got it. Any questions on 74 besides 36? Going once? Going twice? So, let's grab number 36. I'm just going to go ahead and grab his function. Hopefully you guys understand where this partial fractioning thing came from. I'm going to get in your notes and write them down real fast. Just so that we see the techniques always work, cool kids. No need to be scared. We got some intimidation last night, maybe, or the night before, whenever you were working on. But if at first you don't succeed, what should you do? I know, it's not your favorite thing in the world to do. However, if you don't try again, when it really counts, you're not going to do it.
Look at that knowledge base.
Now, does that mean that we always have to try perfectly? No. We don't demand perfection. We just strive after improvement. Isn't that the Christian life, guys? The good thing is, the Christian walk, we have a whole lot of grace to help us. Math, we have a whole lot of grace to help us too, but grace to help us. Gotta make sure we're not tempting God. That's a sin. Okay. Let me get my notes up. Hopefully they're happy. They were not happy last class. Oh no. Like an example would be telling someone like God is all powerful, so I'm gonna stand on top of this building and jump off. That kind of thing. That'd be tempting. Is that the when Jesus tempted him?
Yeah, it's is it Matthew 4? I think it's Matthew 4.
Yeah,
It was in Mark though, I remember that project, because we
might be
Over
It corresponds to when they were on top of the temple and Satan told Jesus to jump off. But Jesus was a portrayal of humility, not a portrayal of, and that's why everybody rejected him in the day, huh? They didn't want a humble Savior. They didn't want a lamb, they wanted a lion. Steve, this is not working. Hold on, guys, I'm trying hard.
let's go computer.
Alright, I'm doing the old school. I'm opening up the old notes just in case we're in trouble. It looks like maybe we are. Can someone go to my computer real quick and do Control-Alt-Delete just once, not twice, please, just once. Kristen, you're my hero. Oh, you're distracted today.
Did it work?
Yeah.
I'm sick.
A lot of people are getting sick, and I'm getting sick.
Please, I'm about to leave. I'm trying to go on sound. XXX. Don't give it to me, please.
Gave him a rose.
What?
It feels like, oh, nice.
Try again. Incorrect. Okay, so
45 minutes.
Alright, focus guys, number 36. Some of you got it right, so just walk me through it. Those of you guys that didn't get it right, where did we get stuck? Alright, hold on. Who do we put above x plus 2?
3.
How about x minus 2?
3.
How about this guy because he's quadratic?
3x plus b.
You got it. Okay, so we didn't get stuck there. Why didn't we factor him more? He's irreducible. We can't. He has imaginary roots. That doesn't work. Okay, what do we do to both sides? What's the system? Yeah, multiply by everybody, right? Everybody. I'm running out of room, so I'm going to write the other everybody over here. This guy, can I just kind of like, everyone's here and they're all going to cancel out, right?
Yeah.
X squared plus 2. Yeah, shoot, shoot. Okay. Now we end up with x squared's on his own. Can you guys, have you gotten in the rhythm of who's going to be left when we come to A? Good. You guys getting the rhythm down? Take away the 1, keep the rest. Plus, what's going to happen when we come to B?
X plus 2 and x squared.
Okay. What's going to happen when we come to CX plus D?
X plus 2 x.
Now why? Because I've already heard someone say, why not strategic values? Why might we not want to do the whole x cubed, x squared, x, and then constant grouping with colors thing? Why are some of you like, that doesn't look fun? It's still good method. But why doesn't it look fun for this one? Yeah, you're going to have to foil him, you're going to have to foil him, you're going to have to foil him, you're going to have to combine all of them. It's not bad. But you can. Ella, you did that? Yeah, it works, right? But some of you were like, hey, let's try that strategic value thing. And since we didn't review it yesterday, let's go ahead and try. What's one strategic value you would plug in?
2.
Yeah, 2 sounds good.
So good.
How about -2 also? And then it's not up there, but what's something else easy to plug in? Yeah, I'd do 0, maybe even 1. Let's see if that's enough. Okay, where are we plugging it into? The x value for this whole shebang, true? Now guys, I'm going to do some mental math. Make sure you double check my mental math, yeah? I wasn't paying attention. Aw, look at Kristen thought my mistake was fun.
Awkward.
Focus crazy. Fun at the front. Okay, so plugging in 2. We can say 4, yeah? Equals. Why am I going to put a 0? Because that's going to cancel, true? Okay, then I'm going to put plus b times 2 plus 2 is 4. 2 squared is 4 plus 2 is 6. Mental mathers, you should like this method. We're just plugging in and doing numbers, right? Why am I going to put plus 0 for the last one? You see where x minus 2 is and how it's canceling out? Right? So that term cancels when you plug in 2, that term cancels when you plug in 2. So now, can't we just solve and we end up with b is equal to, divide by 4 and then divide by 6? Hey, we got one. We got you $1. Just kidding, we got one. Now what? Let's try the next one, huh?
Yeah.
Alright, so plugging in -2, we get 4 again. We okay?
Yeah.
Which terms are going to cancel out with -2? Anything with x plus 2, yeah? Those are going to cancel, so all we're going to have is a times -2 minus 2 is -4. -2 squared is 4 plus 2 is 6. Yeah? Okay. Get rid of all these little things I just took. I should have gotten rid of them earlier. Oops. Then we end up with a is equal to, divide by 4 cancels, divide by -6, a is equal to -1/6. Okay, we're off to a good start. Who else do we need? We're almost there. C and D. I'm going to plug in 0, but I'm not just going to plug in 0. Who else am I going to plug in? Yeah, we got him. Why not plug him in? That's the key for those of you guys that got stuck right about here. So now we got to plug in. Now it's not pretty. We got 1/6, but we have a way to get rid of those, like multiplying both sides by 6. Plugging in 0. 0 equals A, negative 1/6, times 0 minus 2, times 0 squared plus 2, plus B, positive 1/6, 0 plus 2, 0 squared plus 2, plus C times 0, plus D, this is nice, 0 plus 2, 0 minus 2. If you guys really, really, really hate the sixes, the sixths, you guys getting that's a fraction, the sixths, to multiply both sides by 6, right? On the left we get 0, on the right we get, negative 1 times negative 2 times 2, which would be positive 4, right? Plus, here the sixths would cancel, we would get 4 again. Here, the C and 0 has already canceled. We'd have 6 times 2 times negative 2 times D, which would end up with negative 24D, right? Mental mathers, we okay? Cool. Then we go ahead and subtract 4, that'd be negative 8, divide by negative 24, I believe we get positive 1/3.
Yeah.
Nice. We only got one more little guy to find. Who's that? C. Now, we technically know the answer, and we know the answer should be 0, because C does not show up in the answer at all. But to be safe, we wouldn't know that to begin with, would we? So we need one more strategic value. 1 squared is 1, equals A, we already know it's negative 1/6, times 1 minus 2 is negative 1, 1 squared plus 2 is 3, plus B is 1/6, 1 plus 2 is 3, 1 squared plus 2 is 3, plus C times 1, it's going to stay, plus D, which is 1/3, times 1 plus 2 is 3, times 1 minus 2 is negative 1. If you guys don't like the sixths, again, what could you do? Yeah. Multiply both sides by 6 to get rid of all the sixths. We end up with 6 is equal to, bring them in, that's negative 1, negative 1, 3. Multiplied all together, that's 3. Plus, 6 is canceled, 3 times 3 is 9. Yeah, 1 plus 2 is 3, 1 plus 2 is 3, okay. Plus, we're going to see here, for the 6 there, we have, let me do it this way. 6 times 3 is 18, negative 18, times C plus 1/3, just to make it easier, right? Let me bring that in. The 3 and the 9 can become a 12. You can subtract the 12 to the other side, so we have negative 6 equals negative 18C minus 6. Add the 6 to the other side, we get 0. Divide by negative 18, we get. And this all leads us up to the final answer of, take the A, which is negative 1/6, over x plus 2. Take the B and pair him, 1/6, with x minus 2. Take the C, it's 0, it's not there. Take the D, that's 1/3. Pair it with the x squared plus 2. And as you guys saw in the answer key, you can write that many different ways. You can get a little common denominator, like make that guy a 2/6 and then pull out a 1/6 in the very, very front. You could bring those little common fractions, or I should say complex fractions, you can bring the denominators down and just have the 1. Bring the denominator down and just have the 1. Bring the denominator down and just have the negative 1. There are lots of ways of writing it, but that's the long story short of the answer. Cool? Ella, what do you think? Easier or about the same as what you did? Harder?
I guess.
You got stuck. Yeah, all the foiling, she tried all the foiling and the color matching again. This is just not a fun one with either method, but it's possible. Okay, so hang in there. Any questions on 36, the method? Does the system work? Yeah. Do we like that it works? Probably not. We wish it didn't work, but it does. All right, cool kids. Our goal right now is 7-6. What on earth is going on? I said yesterday it's basically just everything we've learned applied. You guys already wrote down this stuff. What's going on? Finding the maximum or minimum. Linear programming, that sounds kind of computery. What? An optimization strategy. Optimization, real quick, can you guys highlight that word? We've actually already done some of this optimization-y stuff. But it was last semester. It was a special worksheet we had. Pre-Cal didn't even, no, they didn't see it. Would have been too rough. A certain worksheet where we did things like the maximum or minimum value of and at, and then we had certain things like fences and like corrals with a fence in between, and we were trying to find the maximum yard that can be contained, etc. Maybe you don't remember, maybe you do, but optimization has to do with finding the optimal conditions, but in math it usually applies to max or min. Usually it applies to max or min, finding the maximum or minimum. And we've already talked about this before as to why you want to maximize, like maximize your profit, minimize your cost. We already had that class discussion with the worksheet last semester. So let's not stress too much. Besides reminding ourselves, if we're trying to maximize or minimize, then the objective is whoever we're trying to maximize or minimize. Our objective function is the objective. Who do we want to get to be the highest or the lowest? And the constraints, well, you guys have heard that word before. What are constraints? So, you think of like if someone's in like custody or if someone is in prison, the constraints are usually like their shackles, right? Whatever's holding them in. Like in the olden days, not so much anymore. But the constraints. But in a math equation, it would be like the restrictions. And you'll see what that looks like as we go on to some examples. Okay? Feasible solutions. We have to figure out a feasible range in order to figure out what solutions are even possible. It's going to be all sorts of different solutions. Then we're trying to find the max or min. So how does this work? How does this work? This is the biggest key. This right here. An optimal solution will occur at a, wait, we've seen that word before. Last section, in fact. Who's this guy? Who's a vertex? Remember, it's the intersection points between each of the different systems. Or I should say each of the different equations in the system. Remember how we did like blue and green and pink and blue and green and pink? Remember? We had to match them up and find the different solutions. Those are called the vertices, and the reason why we learned them in 7.5 is because they're so important in 7.6. They're going to give us the possible answers. They're going to give us the possible answers. Highest one wins if you want to max, lowest one wins if you want to min. Kind of. Highest one wins if we want to max, lowest one wins if we want to min. Kind of. So the long story short of it, I can highlight if you guys want to shorten. We're going to sketch the system of inequalities. We're going to find the vertices. Then we're going to test the vertices by plugging into the objective function. Then we're done. If we want the highest, if we want the max, we'll choose the highest. If we want the min, we'll choose the lowest, meaning the one that makes the objective the highest or the one that makes the objective the lowest. That's it. Sketch like 7.5, find the vertices like 7.5. The only new thing is test. That's 7.6. Write down as many words or as few words as you want. Just make sure you get the optimal solution. What we're trying to solve for must occur at a vertex. So we sketch the region, we find the vertices, we test the vertices by plugging into the objective, and choose the highest if that's what we want. We choose the lowest if that's. So guys, in section 7.6, you might have some word problems. Once again, do not write down for the problems. Remember, you're writing directions and problems like always, but don't write down the English for the problems. Try to translate into math. Does that make sense? Try to write down your systems, and then you can graph them, you can sketch them, you can shade where you need to shade. Show me your work by saying, here are the vertices, and then here's my table of me plugging in, and here's the guy who won. Done. Okay? Don't stress about writing all the words. Sketch, find the vertices, test the objective at each vertice, and choose the winner. Winner, winner, chicken dinner. You guys ready? Now this one, whoo! Phrase, no words, right? This one, no words. Wait, what? Huh. Why is the z one our objective function? Well, who do they want a max of? That's why these are objective function. When they say find the max of, they're telling us our objective, even if it's not labeled over here to the side. So even if this wasn't here, which it probably won't be, as soon as we read maximum value, booyah, that's our objective. Subject to the following constraints. Okay, once you find the objective, you kind of put them off to the side and say, hey, you're important, but hold on, I got to figure out my constraints first. Hey, what are our constraints, guys? Equations or inequalities? Inequalities. What do the first two tell us? What quadrant are we looking in? Yep, if x is positive and y is positive, we're in quadrant 1 right away. Could we go through and actually give them colors? And could we go ahead and sketch them and say, hey, okay, what are your inequalities? I suppose. You could. We could do x equals 0, and we could say, okay, everything greater than u is good. We could do y greater than 0 and say everything greater than u is good. But what are we going to get as our overlap? Yeah, we're going to get the first quadrant as our overlap. So we just made our graph messy, and we haven't even done the last two. So that's why I'm just going to say, hey, let's just look at the first two and be like, you know what? We just know we're only looking in the first quadrant, okay? First two alone. We know we're looking in quadrant 1. Okay, now let's go ahead and look at the second two. Taking them off to the side, and what am I going to solve for like you guys did last night? Yep. I'm going to do it quickly just because we've done this, yeah? Let me get rid of the constraint just because he's in my way. Alright, let's get rid of the objective function. Okay, are you guys solving for y's? Okay, most of them. What did you guys get?
1.5.
Close, -1/2. Good. Plus 2? So as we come down here, I'm going to go ahead and color code just for sake of keeping things consistent. It's not a necessity, but it does help. I think it helps anyway. So I have plus 2. With green. I have down 1/2. Down 1/2. Dashed or solid? Because it's already equal to. Good so far? Yeah. Okay, -1. Up 1/1. Up 1/1. Hey, I found a vertex. Do you guys see it? Nice. Hold on, wait, I need to figure out the shading for each of these though, right? Okay, so the green one was less than or equal to. Have you guys figured out less than or equal to is pretty much below as long as it's something that has a below?
Yeah.
Sweet, let's just use that then, huh? So he's below. The blue one, greater than or equal to, is going to be above. And we know we're only looking in the first quadrant. Do you guys see where we're going? right here. Yeah? We pick a darker color. Right here. Now, what are the vertices for this region? That gets a little bit harder, but can I zoom in? First quadrant, that's bounded by 0, 0, right? It's also bounded in this one by 1, 0. If you carefully graph, maybe you can get your vertices without solving. So I have 1, 0. I have 2, 1. I have 0. How did that happen? Oh, 37. Who's this guy? 0, 2. Now hold on, give me 1 second. We got this. We're going to test the vertices with the objective. We're going to plug in each one. Wait, where on earth are we plugging these guys into? And they asked us for the maximum, which means we're picking the highest. Pick the highest. Kiddos, there's one of these on the test on Friday, but there are not a lot. Let's just try homework, see how it goes. Cool? Come tomorrow with questions, and I'll maybe go over the questions of the ones that are most pertinent to our review. Sound good? Alright, we have another day on this, don't worry, we'll be alright, but I would start on homework as much as you can. Bye, cool kids.